asking questions. Okay, we are recording. So, what questions do you guys have? Welcome, Andrew. I was just asking what questions everybody had, and everybody wants somebody else to ask the question, I think.
I just have a question in general.
Okay, go ahead.
So when do we use the formula like the A equals PERT, or the other one where it's like the A equals the principal in parentheses, like those formulas?
Yeah. So does anybody know the answer to that question?
I know like the PERT is like the continuous, like if it was continuously multiplied, so then
the other one is not continuous then.
Okay, so then we wouldn't. Well, I guess
so that would be daily or weekly or monthly or yearly or whatever. You're going to use the 1 plus r over n to the nt power.
Okay.
Okay, any other questions?
Could we go over some of the like logarithm and natural log ones?
Okay, do you have a specific problem you'd like to go over?
On the first study guide, pretty much just any of them on the front page we could do.
The first study guide?
Mm-hmm. Like I don't remember how to even do the first one.
Okay, let me pull it up here. So that, okay, wait a second. What's the name of the review?
The 4.1 to 5.1.
Oh, okay, so, okay. That I would have called that the third one. The first one for today, okay. All right, okay, so let me share my screen. All right, so the first problem you don't know how to do?
Yeah, I just can't really remember the process.
Okay, so it's 2 to the 7 minus 3x equals 1/4. Does anybody have any ideas? I'm going to try to copy this. I don't know how well it's going to copy, though. We'll see. Any ideas where to start on this one? Yeah, that didn't copy very well. Here's what I'm going to do. I'm going to do it this way. 2 to the 7 minus 3x equals...
Sorry, my siblings are sitting next to me.
Oh, you didn't turn your camera on, so we can't see. So I guess you're lucky. Okay, so anybody have any ideas how to solve this exponential equation? I tried to make that look like it's in the exponent.
Wouldn't we want to get the same base? So like turn the 1/4 to 2 to the -2?
That's correct. That's exactly right. So we can write 1/4 is 2 to the -2. Does that make sense?
Yeah, because then it's 2 on both sides.
Exactly right. So I will copy this. Whoops. And then now that we have the bases the same, we just put the exponents the same, and then it's really easy to solve.
Wait, did you take log base 2? I'm sorry, what did you do again?
Yeah, I didn't do any logs. So I solved this one without logs. Now, your first inclination may be to go to logs, and that will be true a lot of the time, but it's better if you can get the same base. So if you can write 1/4 as so that one way to write that is 1 over 2 squared, or as Bailey said, you could write that as 2 to the -2. Now I've got the same base on both sides, and now I just set the exponents equal to each other.
I don't get why it's 2 to the negative 2.
Okay. So do you agree that this is that 1/4 is the same as 1 over 2 to the second power?
Yes.
Okay. So I can rewrite 1 over 2 to the second power as 2 to the minus 2 power.
Oh, I see what you did.
Yeah. Okay. So yeah, and a lot of times because we get so stuck in logarithms, we forget, oh, if you can get them in the same base, do that. That should be your first choice. And since we can do that on here, that's not only it's a better way to solve it. Now, if you can't get it, if this was a 5, obviously you can't do that. But if it's a 2, 4, 8, 16, anything like that, then that's a much better method. Okay.
Mm-hmm.
All right. So, any others on this page you want to go over? In fact, here, let me do this one, Hallie. Let's do the second one. I'm just gonna take it. So can you, and I'll try to write this with exponents, which is really hard. So, but 25 to the x power equals 1 over the square root of 5 equals, oh my gosh, equals 1 divided by the square root of 5. I can't do that one any other way. Okay. So can you do the same method we did on this problem on this problem?
Could you do, would you square it? Are we trying to get it so we turn 1 over square root of 5 into 25 so it's the same base?
You could do that, but there's an easier way. Can you write 25 in the base of 5 rather than 5 in the base of 25?
Oh yeah, so you could do 5.
So that's 5 squared, right?
Yeah.
5 to the second power, and then I've got to the x power.
Right.
So that makes this 2x.
Right.
And then how can I write 1 over the square root of 5 with a base of 5? 5 to what power?
5 squared.
No.
Wouldn't that cancel this? Are we trying to cancel the square root?
Well, this is in a fraction, right?
Okay.
How can I write the square root with an exponent?
Would it be 5 to the 1/2?
Yes. So this would be 1 over 5 to the 1/2 power. And can I write this with a negative exponent?
I don't know.
Yeah, it would just be 5 to the negative 1/2 power. Ah, you stinker.
Where did the square root go on that?
So, okay, so I'm rewriting the square root of 5 as 5 to the 1/2 power. So I got rid of the square root that way. So it's still in the denominator.
Oh, did you turn?
So think of it this way. The square root of x can be written as, that's the same thing as x to the 1/2 power.
Okay.
Okay. So are you good with me, Hallie? Are we on the same page now?
Yes.
Okay. So now I've got the same bases, and so now I just set the exponents equal to each other, and then it's a piece of cake to solve.
Okay, that makes sense. Thank you.
Okay. All right. Any others? That third one's a good one. Fourth one's a good one. Fifth one's a good one. They're all good. I like all of them. And I'll bet you guys hate all of them. Am I right? Every one of these problems on this page are good.
The section asking you to put it in a decimal, could we do one of those?
So let me just mention that we can solve this equation. I think it's good. I probably won't ask you to use a calculator to find this. So your answer will be, well, yeah, I mean, I'll show you how to get the decimal, but I'd rather you didn't in this case. So let's do this one.
Are you writing the final, or is the math department writing the final?
The math department's writing it. I don't get to.
Okay.
So, okay, so the next one, 5 to the x, 5 to the x equals 20. Okay, how would you solve that?
You would
Which problem?
This is problem number 4, sorry.
Oh, okay. Do you need to find a common base again?
Yeah, we can get a common base. We could write this as what?
I'm not sure.
Trying to decide if getting it in a common base is going to help you, but you can get it in a common base, and that was the first thing that popped into my head. So what are the factors of 20?
1, 2, 4, 5, 10.
So we could write it as 4 times 5, right?
Yeah.
Or 4 times 5 to the first power. I don't know if that's going to help you though. Then this side stays the same. Yeah, that's not going to help you. It's a good thought, but it won't help you. So since we can't really do that, what's the next option?
Would you take the log of 5?
Yeah, do you want to take a base 10 log or a regular log? Or a natural log?
Regular.
So the regular meaning what? Meaning base 10?
Yeah.
Okay. So if we take the log of both sides, now I'm going to have to move this over. So we're going to take the log of both sides. And what happens to my x?
Doesn't it just end up by itself?
What do you mean ends up by itself?
Oh, well. Like taking the log of the 5, it just clears that. So then you're just left with x.
Oh, are you taking a base 5 log?
Yeah.
Oh, you're taking a base 5 log. Okay, I misunderstood you. Okay, so I thought you were taking a base 10 log. Okay, so if you do take a base 5 log, I don't know how to write that. Let me slide that over. Here's what we're going to do. So yeah, I misunderstood what you're saying. So if we do take a base 5 log, okay, log base 5 of 5 to the x, then you are correct. Then x is the case. But if we do that here, now we have to take the base log 5 of 20, okay? Now, so yes, you're correct. So we got to get an x on the left side, and on the right side, we're going to get log base 5 of 20. I'm going to shrink those so they look a little closer, okay? Okay, and so now we can kind of do what we were doing a little bit earlier. We can rewrite 20 as 4 times 5. Okay, so then I've got x equals And now log base, base 5 of, I'm going to write it as 4 plus log base 5 of 5. Now, hopefully you all know, move this because it's going to get in my way. Hopefully you all know what the log base 5 of 5 is.
1.
It's 1. Okay. So essentially this becomes x equals the log base 5 of 4 plus 1. Okay. Now, the problem with taking log base 5 of 4 is I don't have that button on my calculator. And if you do have that button, it's an illegal calculator. Okay. So I can take the log base 5 of 5, and then in that case, yes, this basically disappears on this side. But since I don't have that button on my calculator, normally I would not do that. Okay. So what if instead of doing that, so I'm going to go back to this part of the equation here. What if instead of taking log base 5, I take just the base 10 log, or the regular log. So if I take the regular log, the base 10 log of both sides, okay? And that's what I thought you were going, and that would have been a better way to go. So now this becomes x times log of 5 equals log of 20. Okay. Now how do we get this x all by itself?
Can you divide the log 5 over?
Yeah, that's correct. So I'm going to divide by log base 10 of 5, and this, I'm going to do this log of 5 over here as well. So in that case, x equals just this fraction here. We got the log base of 20 over the log of 5. And so at this point, if you want to get the answer, so let me say this. This is the answer that UVU would recommend that you did. Now, if I wanted to replace that logs with LNs, it doesn't matter. LNs would be perfectly fine. So if you prefer natural logarithms, that's fine. So I'll say this is another answer. If I change that to ln and ln, that's fine as well. Okay. Now to get the answer in the book, I'm just going to say equals log of 10 divided by log of 5, which is 1.43, which is answer.
It's 1.86.
1.86, how did they get that? Maybe. Huh. Do I need to use log 10 of 20 divided by log 10 of 5? Yeah, it is 1.86. Or if I do use the natural logs, the ln of 20 divided by the ln of 5, I still get 1.86. Either way. I don't know what that log function is. I would just assume that was a regular log. Oh, in a base you specify. Oh, wow, Excel has a function there I didn't know about. Okay, that was why I got the wrong answer. That was weird. Okay, so yeah, 1.86 is the answer. So does that make sense?
Mm-hmm.
Yeah.
Okay. What else do you guys have?
On the second study guide, there's a couple questions that ask, tell whether the given rational expression is proper or improper. And on the test we took, you told us not to
Yeah.
worry about it.
Okay. Yeah, don't worry about that.
For the final, don't worry about it.
Don't worry about it for the final either.
Okay.
And if it comes up, I would be shocked. And I'll give you credit anyway, because I told you not to worry about it. It's not on the study guide, is it? On the UVU one?
I'm not sure.
Yeah, I'm pretty sure it wasn't. So do you want to look at the second study guide? Let's see here.
Can we do number 9 on that second study guide?
This one here, 5.2 to 7.2.
Yes.
You said number 10?
9 or 10, I guess, but
9 or 10. Write the partial decomposition. Okay. So let's see how good this copies. I have a feeling it won't copy very well. I was correct, although it didn't too bad. Okay, so we've got a fraction here, x minus 6 over x minus 2, x minus 4. So how do we do the partial fractions?
You're going to put a and b, so a over x minus 2 plus b over x minus 4.
Okay, good start. Then what? These are fractions.
And then don't you get like a common denominator?
Okay, what's the common denominator?
X minus 2 and x minus 4. You multiply
Exactly.
a by x minus 4 and then b by x minus 2.
Perfect. So I need to multiply this by x minus 4 and x minus 4, and this by x plus 2 and x plus 2. Okay. So in the numerator, we're going to get 4a, no, ax, sorry, ax minus 4a. And then on the other one, we're going to get bx.
Wouldn't you be multiplying it by x minus 2?
Oh, I put plus 2. You're right. Should be minus. Okay. All right. So that's bx minus 2b. Okay. And then I have, this is my common denominator. So now that I've got common denominators, I just have to look at these, the numerator. Oh, I'm going to have an x equation, and I'm going to have a number equation. So what's my x equation?
A plus b equals 1.
A plus b equals 1. And my number equation?
Is it negative 4a minus 2b?
And that's going to equal
Negative 6.
negative 6. Okay. 2 equations, 2 unknowns, lots of ways to solve. So we can solve this through substitution, elimination, inverse matrices, Gaussian matrices, Cramer's rule. Am I missing anything? No. Didn't I just name 5 ways to solve? Okay. So how do you guys want to solve this? I'll let Andrew pick since it was his question.
do elimination.
Okay, so how do I, should I eliminate the A's or the B's?
The B's.
So what am I'm going to multiply the top equation by
2.
2. Top equation becomes 2A plus 2B equals 2. Okay, so I'm going to add down, my B's are going to eliminate. I'm going to be left with negative 2A equals negative 6 plus 2 is negative 4. So therefore A equals what?
Negative 2.
Positive 2.
Positive.
That makes sense? So if A
Yeah.
is 2, and then I can plug it back into my first equation, right? 2 plus B equals 1. So 2 plus B equals 1. So therefore I subtract 2. B equals
Negative 1.
negative 1. So what are my partial fractions?
Two over x minus 2. And then negative 1 over x minus 4.
Okay. And there you have it. Those are your partial fractions.
Could we also do number 12 from this section?
12. Is that partial fractions too? Okay. Number 12, we're going to try this one. So the hardest part about number 12 is the setup. So if you get the setup wrong, you got no chance. Okay, so this is 4x cubed plus 3x squared, and then I think this x squared, this is in the bottom. Okay, so hopefully you can understand where the exponents are. And this is my fraction. So how do we set this up?
Your denominators are going to have, it's going to be x squared plus 5, and then you're going to have an x squared plus 5 to the second, and then x squared plus 5 to the third.
Yes.
Perfect. X squared plus 5 to the second power. And that same thing to the third power. So it's repeating quadratic factors, right? By the way, can I factor this any more than I already did?
No, you can't.
Not with real numbers. You can do it with imaginary ones, though. Okay, so then what goes on top here?
AX plus B.
Very good. AX plus B goes here.
CX plus D.
CX plus D. And
EX plus F.
okay, did everybody agree with that? Okay, so now this is my common denominator, right? So now what do I multiply the middle one by in order to get this?
By x squared plus 5.
X squared plus 5. Okay. And then probably should have given myself more room. What do I multiply this one by to get
X squared
this?
plus 5. X squared plus 5 squared.
Okay. Okay. So I'm going to FOIL out this x squared plus 5 squared before I multiply it by the x plus b. So this is going to become x to the 4th plus 10x squared. Actually, here's what I'm going to do. I'm going to do that, but I'm going to put it in columns because it'll make my life easier. So the 5 times the x squared is going to be 10x squared. And the 5 squared is going to be, in fact, here's what I'm going to do. I'm going to move this over. And then I'm going to have an x term, and then I'm going to have 5 squared, which is 25. No, I'm not going to do that. I changed my mind. Okay, so x to the 4th plus 10x squared plus 25. Now, I still need to multiply that by ax plus b, which I will do in just a minute. Okay, then we need to multiply these two together. So this becomes cx cubed plus 5cx. I don't know, I didn't mean to capitalize. Plus dx squared plus 5d. Okay. And so then the ex plus f doesn't change. Ex plus f, so I didn't need to multiply that by anything. Okay. Now I need to multiply this times that. And now I'm going to start putting it into columns. So ax times 4 is ax to the 5th. Ax times 10x squared is going to become 10ax cubed. Ax times 25 is going to become 25ax. Now I need to do the b term. So that's going to be bx to the 4th and bx squared and then 25b. Okay. Now I'm going to line this up. So I've got my cx cubed. So I'm going to put that in this column, cx cubed plus 5cx plus dx squared plus 5d. Then I'm going to add my ex, x, and then I'm going to add my f. Okay. All right. So essentially what we're going to do here, I need to come up with an x to the 5th term. And so I didn't mean put, okay, so my x to the 5th equation is going to be just a, because that's the only x to the 5th power. So what does a equal? What's that equals the x to the 5th term in the root? So a is going to equal 0, right? So a is going to equal 0. A equals 0. Okay. Now I need to come with an x to the 4th equation. In this case, x to the 4th is going to be b. B is also going to equal 0. Okay. So a equals 0, b equals 0. So essentially, this first fraction is going to drop right out. It doesn't really exist. Okay. Then I need to come up with an x cubed equation. So that's going to be 10a plus c equals, now we need to come up with the x cubed term, which is 4. And since a is 0, then essentially then this becomes c is going to equal 4. Okay. So that was really easy. X to the squared term is going to be this column here, which is going to be b plus d, and that has to equal the x squared term up here, which is -3. And we know that b is 0, so in this case, d equals -3. Wow, I thought this one was going to be hard. It's going to end up being easy. Okay, then we have our x equation, which is going to be this column here. So I've got 25a plus 5c C plus E is going to equal, that's my X term here, which is going to equal 14. Now A is 0, so that's going to drop out. So I'm going to end up with 5C. 5 is 5 times 4 plus E equals 14. I'll subtract 20 from both sides. And I'm going to get E is going to equal -6. And then I just need to come up with my number term, which is what's the E? F. F equals -20. F equals -20. Oh, is that right? No, that's not right. This actually, I didn't realize that should be in this column. So yeah, so I got 25B plus, here, I'll keep it close, plus 5D plus F equals 20, equals -20, right? I'm off the page. So that equals -20. Here, let's move this over so we can see it. Okay, so 25, so B is 0, D is -3, so 5 times -3 plus F equals -20. So I'm going to add 15 to both sides. In this case, F equals -5. See, that one wasn't near as bad as it looked like, right? So this fraction just drops out. That doesn't exist anymore. So C is 4. So I'm going to end up with 4x plus D, which is -3. So I'll just change that to -3 over x squared minus 5. And then E is -6. So that's going to be -6x minus 5. And that's going to be over this. Okay. So I guess in between I would have a plus. So that's your answer right there. So that wasn't too bad, was it? Or was it?
No, that was okay.
Yeah. It looked scary because you started with an x to the 5th term, but then those two fizzled out pretty quick. Okay, what else do you guys have?
Could we work on problems either that involve Cramer's rule or, I guess, solving for the value of the determinant? I'm just confused on, I was looking over my notes and I was getting confused on things like, sorry, one sec. Things like the row echelon form still confuse me, or where you have to get like a diagonal of like ones in the matrices.
Okay, so you're asking two different things. So here's a Cramer's rule problem here, and here's a Cramer's rule problem here. Those are different than the row operations or row echelon form, which would be these two problems. So,
Do you know which one we would see more of on the final?
you know, I haven't done what. Probably, let me see. What is the? Let's look at the common final question types, because I can't remember what they asked. That would probably be a better. Oh, I already had it open. Oh, actually, here we are. We got Cramer's rule right there. Here, I just had it open. So on the common final, they told you these are 3 Cramer's rule problems. And, oh, this is inverse matrix. So here's what I will say. I did the first problem in my earlier class today. So if you want to see that one solved, I did that one already. That's already recorded.
Okay.
I did not do a Cramer's rule. And you're talking about also Gauss-Jordan. So do you want to do, we're not going to have time to do both of those. Do you want to do Gaussian or do you want to do Cramer's rule? Because those are both on the common final.
Either one works, honestly.
You pick, it's yours.
Let's just do Cramer's rule.
Because we're kind of short on time, so I'll do the easy one. So we'll do this one, Cramer's rule. Or we could do one of the other ones, but it doesn't matter. Okay, so I've got Cramer's rule here. Solve using Cramer's rule. Okay. So essentially, we need to find, so x, so as a quick reminder, x equals d sub x divided by d, and y equals d sub y divided by d. So we need to find d, we need to find d sub x, and we need to find d sub y. I'll try to hurry because I know we're kind of short on time. So d is just going to be the coefficients right here. So that's going to be 2, 3, and 10, -5. Okay. So if I were to draw this as a matrix, I would draw those in lines, and I'm just going to find the determinant, which is going to be 2 times -5 minus 3 times 10. Okay. And so 2 times -5 minus 3 times 10. So your determinant is -42. So that's going to be your denominator in both of these equations.
You accidentally put in the 6, so it's actually -40.
Oh, you're right. 2 times -5 minus 3 times 10. That's correct. It should be -40. Correct. So that's going to be your denominator for both of these.
Mm-hmm.
Now, can you tell me what the matrix is for d sub x?
It's going to be 11, 10, 6, -5. If I'm going to
Okay, so if we read it in columns 11 and 6 and 10 and -5, right?
Yeah.
You said it in a different order, but that we meant the same thing. Okay, so if this is the matrix, then all we have to do is find the determinant, which is going to be simply 11 times -5 minus 6 times 10. So that's going to be -75. So in this case, x equals -75 divided by -40, which works out to be 1.875. or those are both divisible by 8, so, or by 5. So that would be, if we left that as a fraction, 5 goes into 70. 5 goes into 75. 5 times 1 is 5 to 15 over 8.
Wait, where did you get the 75? Wouldn't you do 11 times -5 minus 6 times 10?
Oh, you're right. I wondered why. I put 2, but I meant 6. Yeah, 6 times 10. There we go, which is, yeah, 11 times -5 minus 6 times 10. It's much easier to do this on paper. Correct. So that would be -115 over 40, which is 2.875. Leaving that as a fraction, those are both divisible by 5. Still going to have an 8 on the bottom. 5 times 2 is 10. 3, -23 over 8. Okay.
Mm-hmm.
That doesn't seem right to me, but I think it is. Is that one of the answers over here? Oh, they didn't give you the answer. Okay, so then,
Since the numerator and the denominator are negative, would it be positive?
yeah, that's what I meant. 23 over 8. All right, so your d sub y is going to be 2 and 3 and 11 and 6. So when we find that determinant, that's going to be 2 times 6 is 12, minus 3 times 11 is 33, which is -21. So in this case, y equals -21 over -40 over divided, which is 0.525, or I'd probably just leave that the way it was. I'll get rid of the negatives though. So 21 over 40. I'd probably just leave that as a fraction. So 23 over 8 and 21 over 40. I'm surprised they gave you one like that. Usually they like to give you whole numbers, but. Okay. Do you feel good on Cramer's rule, Hallie?
Yeah, that makes a lot more sense. Thank you.
Okay. All right, well, I think we're out of time. So I will recommend the earlier class, ask completely different questions. And so you may want to watch their video and they may want to watch yours. And you might want to check their class, because they asked completely different questions than you did too as well. So. Sound good?
Mm-hmm. Thank you.
Okay, and so I'll give everybody a point today for being here. And we'll see y'all later.